Hello students, I am Subhashish. In our previous session, we have learnt about the solutions of linear equations. The number of solutions that can be determined for linear equations in two variables and the ordered pair of solutions. In this session, we will learn some more different examples of linear equations in two variables in which we need to find the constant value and verification of the solution. Let us see the learning outcomes for this session. Learning outcomes. After this session, students will be able to solve the linear equations in two variables to find the constant value. Verify whether the given ordered pair is a solution or not. Understand the graph of linear equations in two variables. Keywords: linear equation, graph, substitution, variables, constants, solutions. Let us recall a few points from our previous sessions and previous classes. The linear equation in two variables is of the form ax plus by plus c equal to 0. A linear equation in two variables has infinitely many solutions. To find the solution of a linear equation in two variables, by putting the value of x equal to 0, we get the value of y, and by putting the value of y equal to 0, we can find the value of x. Now, let us recall an example problem of linear equations in two variables. Example: let us consider an equation x plus y is equal to 5. When we substitute x equal to 0, we get y equal to 5. In the similar way, when we substitute y equal to 0, we get x equal to 5. We get two solutions. The two solutions of the equations can be written as ordered pairs 0, 5 and 5, 0. Note: if a, b is a solution, then there is no need that b, a is a solution for an equation px plus qy plus r equal to 0. Students, this we already knew, right? Yes. Let us suppose a linear equation in two variables is given with an unknown constant value and its solution is given. Can we find the value of unknown constant? Yes, we can find the value. By what method we can find the value of unknown constant? Yes, we can find the value of unknown constant by substituting the solution, that is ordered pair, in the given equation. Let us see some examples to learn it. Example: find the value of p if x equal to 2 and y equal to 1 is a solution for the equation 3x plus 4y is equal to p. Solution: given equation is 3x plus 4y is equal to p. Now we need to find the value of unknown constant p. By substituting x equal to 2 and y equal to 1, after substituting we get 3 into 2 plus 4 into 1 is equal to p. After solving we get p is equal to 10. The value of the constant term is p, which is equal to 10. We can say that we can find the unknown constant value by substituting both x value and y values of the solution in the linear equation in two variables where x and y are variables. Let us see one more example. 7x plus y is equal to 5t, where the ordered pair are 2, minus 4. Given equation is 7x plus y is equal to 5t. Now we need to find the value of unknown constant t. By substituting x equal to 2 and y equal to minus 4, we get 7x plus y is equal to 5t. By substituting x and y values, we get 7 into 2 plus 1 into minus 4 is equal to 5t. After solving, we get 14 minus 4 is equal to 5t, where t equal to 2. The value of constant term is t, which is equal to 2. Let us see another example. 6x plus 5y is equal to t, where ordered pair are 0, 1. Solution. Given equation is 6x plus 5y is equal to t. Now we need to find the value of unknown constant t. By substituting x equal to 0 and y equal to 1, we get 6x plus 5y is equal to t. After substituting the values, we get 6 multiplied by 0 plus 5 into 1, which is equal to t. By solving, we get t equal to 5. The value of constant term is t, which is equal to 5. Students, if the constant value is known, then how can we verify an ordered pair is a solution or not? Let us check. Example. Which of the following are the solutions of the equation 1 by 2x plus y is equal to 4? Where 2, 3, 1, 4, 4, 2, 6, 1, 5, 3. From the following solutions, we need to check every solution, that is, substitute x and y values in the given equation to find the solutions of the equation. After substituting x and y values in the equation, if LHS equal to RHS, then we can call the pair as a solution of that equation. For given solution 2, 3, the given equation is 1 by 2x plus y is equal to 4. We need to verify whether the given pair is a solution of the equation or not. Substitute 2, 3 in the equation 1 by 2x plus y is equal to 4. We get 1 by 2 into 2 plus 3. After solving, we get it as 4. The left hand side equation is equal to right hand side equation. We can say that 2, 3 is the solution of the equation 1 by 2x plus y equal to 4. For given solution 1, 4, the given equation is 1 by 2x plus y equal to 4. Substitute 1, 4 in the equation 1 by 2x plus y equal to 4. We get 1 by 2 into 1 plus 4. After solving, we get it as 9 by 2. Which is not equal to 4. The left hand side equation is not equal to right hand side equation. We can say that 1, 4 is not the solution of the equation 1 by 2x plus y equal to 4. For given solution 4, 2, the given equation is 1 by 2x plus y equal to 4. Substitute 4, 2 in the equation 1 by 2x plus y equal to 4. We get 1 by 2 into 4 plus 2. After solving, we get it as 2 plus 2, which is equal to 4. The left hand side equation is equal to right hand side equation. We can say that 4 comma 2 is a solution of the equation 1 by 2x plus y equal to 4. For given solution 6 comma 1, the given equation is 1 by 2x plus y equal to 4. Substitute 6 comma 1 in the equation 1 by 2x plus y equal to 4, we get 1 by 2 into 6 plus 1. After solving, we get it as 3 plus 1, which is equal to 4. The left hand side equation is equal to right hand side equation. We can say that 6 comma 1 is a solution of the equation 1 by 2x plus y equal to 4. For given solution 5 comma 3, the given equation is 1 by 2x plus y is equal to 4. Substitute 5 comma 3 in the equation 1 by 2x plus y equal to 4. We get 1 by 2 into 5 plus 3. After solving, we get it as 11 by 2, which is not equal to 4. The left hand side equation is not equal to right hand side equation. We can say that 5 comma 3 is not the solution of the equation 1 by 2x plus y equal to 4. Therefore, we can say that 1 comma 4 and 5 comma 3 are not solutions of the given equation, and 2 comma 3, 4 comma 2, 6 comma 1 are the solutions of the equation 1 by 2x plus y is equal to 4. Students, let us see an example of linear equation in two variables on a graph. Example: what is the graph of the equation 5x plus 6y is equal to 12? Solution: consider equation 5x plus 6y is equal to 12. To get the points for the given equation, substitute the different values of x and y in the equation. Substitute the value of x as 0, then we will get y value as 2. And by substituting the value of x as 6, then we get y value as minus 3. Then we get the following table. After plotting the above points, we get the following graph. If you observe the graph, every point on the graph of linear equation in two variables is a solution of the linear equation. Let us conclude the session by discussing some important points. Points to remember. We can find the unknown constant value in a linear equation in two variables ax plus by is equal to u, where ab is known coefficients and u is the unknown constant, by substituting the solution, which is an ordered pair form. We can verify whether the ordered pair given is a solution of the equation by substitution. Every point on the graph of a linear equation in two variables is a solution of the linear equation. Moreover, every solution of the linear equation is a point on the graph of the linear equation. Thanks for watching.